Okay, so today we're going to do negating implications, which is there's no coding and really involved in this exercise. It's just kind of understanding the logic. So I've already got it filled out, but I'm just going to explain where it all comes from. So basically what it means is if A is equal to 1, then B has to be equal to 1. Or in this case, if P is equal to 1, then Q has to equal to 1. So if P is equal to 1 and Q is equal to 1, then this has to be true as well, because when P is equal to 1, Q is equal to 1. That's true. If P is equal to 1 and Q is equal to 0, then the rule that we had made before has to be false. If P is equal to 1, Q is equal to 1, that's just not true here. If P is false, or if P is equal to 0 and Q is equal to 1, it doesn't actually break the rule. If P is equal to 1, Q is equal to 1, because if P is equal to 0, it doesn't really matter. Like, this rule could be true, or it just doesn't come into play here. So for each of these, for when P is equal to 0, this statement is still true. Now we have to think about what the negation of this is. What's the negation equivalent to? Well, we could say the obvious thing what you do is, or you could go, let's negate both of them. So you could say if P is false and Q is false, which that doesn't make sense because then these would be the truth table would fill out very similarly to this truth table here. So this is kind of, we're looking for like an opposite. So what the negation actually is if P is true, then Q is not true. So the negation of Q is true. So I kind of hope that helps. The way the test was made out here was that this had to be exactly typed. So it was a little bit annoying here, but once you figured that out, it was fine. He had his, he had the things to decide here. So you just put them in instead. So it was or and. But hopefully that helps. So I'll just run the test to make sure that that's all right. So that's okay. So yeah, I hope that helps.